This is for Year 11 methods. It comes out of Chapter 16. It's an explanation of average rate of change and instantaneous rate of change, and the two methods we have to estimate instantaneous rate of change. Okay, average rate of change is between 2 points. So you'll find it's the average rate between 2 points. For example, this point and this point, and it's the gradient between them, or the slope of the chord that runs from one point to the other point. So 8 minus 4 over 3 minus 1, 4 on to 2 is the average rate of change between 1, 4 and 3, 8. Instantaneous rate of change is at 1 point. So for instance, it's at that point there. What is the instantaneous rate of change? So unlike average rate, where it's between 2 points and it's the gradient, instantaneous is exactly at 1 point. One method that I have is to draw a tangent. So I would get my ruler and I would put my ruler under here. Then I need to draw a straight line that touches at the point and is tangential to the curve. This one looks as if it's not very straight. And then what would I do? I would use my axis to estimate 2 points on the curve and then do rise over run. And I estimate the instantaneous rate of change by drawing a tangent by hand and estimating its gradient using the grid of the axis to find out what the gradient is. So draw a tangent, find 2 points on the tangent, calculate the slope of the tangent, and this will be the instantaneous rate of change of the curve at that point. Okay. The second method that we have to estimate the gradient at this particular point is to use chords between 2 points, but then I'll move the second point closer and closer and closer to the first. So let's say I start here and I work out the gradient of the chord between these 2 points. And I work out what that is. Let's say it's M1. Now, that gradient isn't really a very good estimate for the gradient at this point here. So I might take my second point and move it closer and work out M2. Then I get another point closer and I work out M3. And then I keep on moving my second point closer and closer and closer to the first point, so that my M4, I can then see what pattern's happening with all of these gradients as we move from further away to closer away, and could it be that this is honing in on a particular value? I'll demonstrate that using an example. Okay, here I've got y equals x squared. I'd like to estimate the instantaneous rate of change of y equals x squared when x equals 1. And I'd like to do it by using chords of 2 points where the second point gets closer and closer and closer to the first. Okay, so I'm going to start where my second point is here at 2, 4. So I'm going to be finding the gradient of that chord that goes from 1, 1 to 2, 4. And that's going to give me M1. And M1 is going to equal Y2, which is 4, minus Y1, which is 1, over 2 minus 1, which equals 4. So my first estimate for the instantaneous rate of change at this point is 4, and it's not a very good one. So let's pick a second point, which is at 1.5. So 3 on 2 and 9 on 4. And I'm going to use this chord as my estimate for the instantaneous rate of change at 1, 1. And I'm going to call that M2. So M2 is going to be 9 on 4 minus 4 on 4 over 3 on 2 minus 2 on 2, which is 5 on 4 on top of a half, which is going to be 5 on 2, or 2.5. And that's my second estimate. I now like to pick another point, and that second point I'm going to pick is going to be at 1.1, 11 squared is 121, so 1.21. And I'm going to call that M3. So M3 is going to be 1.21 minus 1 over 1.1 minus 1, or 0.21 over 0.1, which should be 2.1. Okay, I've got 3 points now. I'm thinking that at 1, it's probably zooming in on 2. The closer I get my second point towards my first point, the more accurate I can be with my estimation. So my last point that I'm going to choose is going to be the point 1.0001, which is 1.00, oh, lost it, 002,001. So it's going to be M4. And M4 will equal 1.002001 minus 1 over 1.001 minus 1, which is 0.002001 divided by 0.001, which is 2.001. That confirms my thought that the instantaneous rate of change at x equals 1 is going to be 2, because I drew chords, and as my gap between the second point and 1, 1 gets closer and closer and closer, I would expect the chords gradient to be closer to the actual instantaneous rate of change. So they're the two methods that I have to estimate the instantaneous rate of change by hand. Draw a tangent and then use the grid to work out 2 points and work out the gradient, and using chords where the second point gets closer and closer and closer to the first. Therefore, I can see what's happening to my gradient from 4 to 2.5 to 2.1 to 2.001.